Hey friend, welcome back to the Sage Audio channel. Today we're going to be answering the question, what is dithering? But we'll also be looking into whether or not it's always necessary by running some tests and the appropriate times to use it. So stick around for the full video, but if you're in a hurry and you need a quick answer, dithering is the process of adding noise to a signal in an effort to mask and randomize higher order harmonics and in turn make quantization distortion less perceivable. Dithering should only be used during the mastering process and only when the bit depth of a signal is being reduced. Before we go any further, if this is a topic you'd like to know more about, I'd highly recommend checking out the blog associated with this video where we go into much greater detail on this topic. If you're on YouTube, just scroll down to the description box below to find the link. Also, if you're an artist or an engineer and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you using solely analog equipment and send you a free mastered sample. All you have to do is set up this short account, upload the song, and we'll do the rest. So, as we said, dithering is used to cover quantization distortion, but when exactly does this occur? Quantization distortion occurs whenever the bit depth of a recording is incredibly low, resulting in a distortion that is similar in tonality to that of a square wave. Now, quantization distortion shouldn't be confused or conflated with quantization noise, which is the difference between the original signal and the quantized signal. At higher bit depths, this quantization noise sounds just like white noise. In fact, if you were to bounce a mix of yours down to say 8 bits, you'd hear more of the effects of the noise than you would the harmonic generation that's often associated with a square wave. Let's take a listen to an 8-bit file.
When I awake, it's such an awful fright.
It's only when you significantly lower the bit depth that you start to hear significant harmonic generation. Take a listen to 2 bits. So what does this all mean for dithering? Well, in an attempt to better understand the different types of dithering that can be seen here at the bounce down screen of Logic Pro, I came across something interesting. I wanted to see the actual differences between the different dithering types, but in turn found that in certain circumstances, dithering might not even be needed. So what I have here is an original 24-bit mix. Below it is the same mix but a 16-bit version created without the use of dither. Next is the 16-bit version created with pow-r1 dither. Then there is the 16-bit version with pow-r2 dither. And then lastly, there is the pow-r3 dither version. By playing the original untruncated 24-bit mix while playing another one of these tracks and inverting the phase of one of them, we'll be able to hear or at least measure the differences between them. This is called a null test and can be used to measure the differences between any two audio files. If this is something you want to try on your own, all you'll need to do is get a utility plugin like this one where you can invert the phase. So let's play the 24-bit version and an inverted 16-bit version, which again has no dithering used. As you may notice, almost complete cancellation is happening, but the quantization noise can still be measured. If we take a look at this true peak meter, we see we're getting a reading of around -74 dB true peak. This is arguably pretty low noise, so the quantization noise generated by bouncing a 24-bit file down to a 16-bit file without dithering isn't too terribly significant. But let's compare this quantization noise to the noise generated from dithering to see how it compares. If we repeat the process by playing the 24-bit file, but now with a 16-bit version created using the pow-r1 dither, we'll be able to measure the noise generated from the dithering. Again, not much signal happening, but on the true peak meter, we have a measurement of roughly -70. This means that the noise generated from dithering, at least in this example, is actually higher than that of quantization noise. Let's continue this process with the next version. So it looks like this version of dither results in a noise of roughly -72. And lastly, the pow-r3 dithered track, let's take a look at that one. Now it looks like the results of this one is roughly -64 dB, give or take. So in all of our tests here, we found that the use of dithering results in noise that is actually louder than if dithering wasn't used. Now, this is just one test and is something that should be tried multiple times and with multiple mixes before coming to any conclusion, but it does, at least to a certain extent, call into question the practical use of dithering. If you do plan on using dither, only use it once and when reducing the bit depth of your recording, otherwise you'll just be adding excess noise to your recording. Do this enough times and this noise will definitely become perceivable to any listener. So, what do you think? Is this something you'd like to know more about? If so, I'd highly recommend checking out the blog in the description box below this video. It's full of great information related to this topic. Also, if you're an artist or an engineer and you have a mix that you need mastered, send it to us at sageaudio.com for a free mastered sample. All you need to do is create the short account, upload the song, and we'll take care of the rest. But thank you so much for watching. We hope you enjoyed it. If you did, you can like and share this video with your friends. Also, you can subscribe to the channel to stay up to date on all of our latest videos. There's also a comment section where you can leave your thoughts on this video or a suggestion for a future video. And then lastly, again, if you're an artist or an engineer and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you and send you a free mastered sample. Thank you so much for watching. We'll see you in the next video.